Hey everyone, in this video we're going to be looking at Chapter 8 of The Effective Engineer, and it's the beginning of Part 3 of the book, which is called Build Long-Term Value. Chapter 8 is called Balance Quality with Pragmatism. The first section is called Establish a Sustainable Code Review Process. It explores the varying attitudes of engineering teams toward code reviews and the benefits and drawbacks of implementing them. For some teams, code reviews are an integral part of their culture, and engineers cannot imagine working without them. For instance, at Google, code reviews are mandatory, and every commit needs to be reviewed by at least one other person before it can be committed to the repository. The benefits of code reviews for these teams are numerous, including catching bugs and design shortcomings early in the development process, increasing accountability for code changes, positive modeling of good code, sharing working knowledge of the code base, and increasing long-term agility. On the other hand, some engineering teams do not perform code reviews or limit them to only specific types of code changes, citing concerns about the impact of iteration speed. For example, Dropbox did not require code reviews for its first 4 years, yet the company was still able to build a strong engineering team and a successful product with tens of millions of users. However, as teams grow, they may face increasing pressure to implement code reviews to maintain code quality and institutional knowledge. The section argues that deciding on code reviews doesn't have to be a binary choice, where all code is either reviewed or not reviewed. Instead, code reviews can be structured in different ways to reduce their overhead while still maintaining their benefits. For example, some teams employ nimbler code review processes, such as over-the-shoulder code reviews, pair programming, or reviewing only the trickier pieces of core functionality. Code review tools, such as GitHub and Fabricator, have also significantly reduced the overhead of code reviews by providing lightweight web interfaces, automatic review requests, and inline comments. The section emphasizes that finding the right balance of code reviews that works for each team requires experimentation. For example, at Quora, they only require reviews of model and controller code for business logic. They review most code after it's pushed to production and frequently review changes to hairy infrastructure internals before they were committed. That may or may not still be the case now, but at least was at the time of the book being written. New hires code received more attention and reviews than senior engineers code as well. The section concludes that teams can experiment with different types and levels of code reviews to reduce friction while still retaining the benefits of code reviews. The next section is called Manage Complexity Through Abstraction. It goes into the importance of choosing the right abstractions in software engineering and how it can significantly improve productivity. It uses the example of Google's MapReduce programming framework, which allowed engineers to easily define parallelized computations over a large distributed cluster of machines without requiring expertise in distributed processing, networking, or building fault-tolerant systems. By abstracting away the complexity, engineers could focus on the application logic, and small teams could easily parallelize computations over massive amounts of data without specialized knowledge. This resulted in over 10,000 unique MapReduce applications being developed within 4 years of its internal release at Google. The section also highlights the importance of choosing the right abstractions in increasing engineering productivity, reducing future application maintenance, and solving hard problems once and enabling their solutions to be used multiple times. The right abstractions reduce the complexity of the original problem into easier to understand primitives and solve hard problems once and enable the solutions to be used multiple times. The section also talks about the trade-offs of building abstractions for a problem, where building a generalized solution takes more time than building one specific to a given problem. To break even, the time saved by the abstraction for future engineers needs to outweigh the time invested. The section recommends focusing more energy on making the core abstractions great, as those are the ones that the team relies heavily on. It also discusses the importance of not over-investing in abstractions up front, as this can lead to delaying the development of the actual product. The section cites an example of Asana, a startup that spent nearly the entire first year of its existence developing Luna, a new framework for building web applications, which then delayed the development of the actual product. The next section is called Automate Testing, which talks about the benefits of, as the name implies, automated testing in software development. It highlights how automated testing, coupled with manual testing, provides a scalable way of managing a growing code base with a large team without breaking the build or the product. Automated testing allows developers to catch bugs early and mitigate against error spikes caused by major feature releases and refactoring of existing code. The section suggests that engineers should add missing tests before modifying a piece of untested code and add a test that the bug breaks before fixing it. Tests also allow engineers to make changes with significantly higher confidence, especially in large refactors, and enable them to identify who's accountable when code breaks. Automated testing provides executable documentation of what cases the original author considered and how to invoke the code. However, the section cautions that building automated tests for everything is not always the best idea, and it is essential to consider the trade-offs. The section also discusses some of the difficulties in fostering a culture of automated testing, such as organizational inertia, concerns about reducing iteration speed, and unclear incentives for writing tests for a product that may not ship. The next section is called Repay Technical Debt. In software development, tech debt refers to the cost of deferred work necessary to improve the quality and health of the code base. Tech debt can accumulate when developers make quick and dirty workarounds, work without fully understanding the problem space, or avoid following design guidelines. Just like financial debt, failing to repay the principal on technical debt can slow down progress and impede the ability to build value. Over time, debt-ridden code can become hard to understand and modify, and engineers may actively avoid it, leading to slower iteration speeds and increased risk of bugs. Effective engineers incur technical debt when necessary to meet deadlines, but periodically pay off the debt to avoid it getting out of control. Different organizations use various strategies to manage technical debt, such as scheduling cleanup work, rewrite projects, or fix-it days. However, it may be up to individual engineers to schedule and prioritize repayment of technical debt against other work. Tech debt can be hard to quantify, but starting small and approaching the problem incrementally can reduce the risk of failure and justify the time spent. Not all tech debt is worth repaying, and effective engineers prioritize repaying debt in highly trafficked parts of the code base that take the least time to fix up. These improvements generate the highest impact for their effort. With all that being said, the key takeaways for the chapter are to establish a culture of reviewing code, invest in good abstractions, and manage tech debt responsibly. So that's all for this one. My name is Daniel, and I make programming-related videos, sometimes coding tutorials, and others more abstract, like book chapter summaries. I do it not only because I love teaching you, but I love learning for myself as well. So if you found this video and this series helpful or thought-provoking, I'd appreciate a like, subscribe, and comment. I love hearing from you, and we'll see you all in the next one.